All right, great. This is Sophie Koch with Honolulu Civil Beat, and I'm here with Steve Oni. Steve, what is your title and what do you do here?
I'm Chief Science Officer with Ocean Thermal Energy Corporation.
And where is it based?
Well, our executive offices are based in Lancaster, Pennsylvania. We have our financial office and some of our technical arm in Virginia, Washington, D.C. area. And our engineering technical group right now is located in Honolulu, Hawaii.
Otec is a really exciting technology for Hawaii, but it remains pre-commercial. Can you explain to people exactly how it works?
Yeah, the Otec technology basically replicates Mother Nature. The world's weather system is driven by the temperature differential between the solar energy stored at the equator, and which moves the ocean circulation patterns, the atmospheric circulation patterns, our tropical storms, etc., is Mother Nature moving heat from the equator to the Arctic zones. And that occurs over thousands of miles. Well, that same temperature differential is available within 1 kilometer vertically in the tropical ocean. And that allows us to be able to harness the energy on a human scale. So we replicate a hurricane by bringing up cold water from the bottom, and we have that same energy potential right there at the shore or on a platform.
And there's also been a lot of obstacles for Otec. One of the issues is that you really need a plant that's, I think, 5 megawatts in order to do the environmental testing, but financing is a problem for that. Where are we right now, and how feasible is this technology in terms of being commercialized and getting those pilots up?
Right. The technical aspects have been primarily or principally addressed for the small-scale projects. What you face is an economy of scale, which makes it very difficult to implement these small-scale projects economically outside of perhaps government-supported research efforts. And that's kind of where the Otec's been left in limbo for the last several decades. To take it from the pre-commercial demonstrations that occurred in the 100 or the tens of kilowatt range to a commercial plant of, say, 10 megawatts or even 100 megawatts, where the economics start to make sense because of the economy of scale, is a difficult process. And to ask the capital markets to actually bear that risk and whatnot is a difficult situation. But we're getting there because of the fact that oil is now escalating, and people are finally at the point where they believe oil is not going to go back down to $30 a barrel, and the susceptibility of the country to the volatility of foreign imported fuel has raised the awareness that we need to start looking at these other technologies. And the reality is like any other technology, as it becomes commercially available, the technology will become cheaper and cheaper because you'll get the attention of the suppliers, and they'll be able to create cheaper, more off-the-shelf components for the process. And
so where are you guys right now in terms of the pilot plants? Are you looking to start building, or are you looking to try to get financing, or where is it right now?
Well, we are not actually looking for pilot plants because we don't work within the government realm. We wouldn't call what we're doing a pilot plant. We would call that a commercial plant. So we are actually working on commercialization of actual money-making projects. And to do that, we've been able to capture the attention of several significant financial partners, as well as some of the large EPCs, which are engineering, procurement, and construction contractors, which are necessary to build and finance these projects. So within a specific niche market application for these smaller plants, to demonstrate the technology at a commercial scale that still is then scalable to larger sizes, we're becoming very successful at that.
Okay, so what size are we talking about? Are we talking about in the megawatts, or are we still in
we're in the megawatts, yeah. I mean, in my opinion, commercialization has to be over 5 megawatts to make any sense. And so, that's a logical step after where we've been with the research. We're now stepping into the industrial or commercial range with a 5 to 10 megawatts, something like that.
Okay, and do you have any sense of where it might be?
I can't talk about particulars, but we feel confident that within the next 3 to 5 years we'll have an operating plant.
And just recently, HECO has been talking about the fact that they're negotiating a 100 megawatt power purchase agreement or contract with Otec company out of Baltimore, Maryland. What does that mean for the industry? I mean, this would be the first time an Otec company had a commercial plant, and on the scale of 100 megawatts, that's really huge.
That's a big deal.
Yeah, I mean, that's the point where it starts penciling out.
Right.
Are we really at that stage in the industry where we can build a plant that big? I mean, have we done the research? Are the pilot plants up? Have we shown that it's not going to have environmental effects on the ocean, and all of that?
In my personal opinion, I don't believe we're ready for that 100 megawatt step. I don't think we're far away from that step. I do believe that we need to make a more conservative baby step, like I said before, in the 5 to 10 megawatt range to demonstrate the system's operation at a scale that's manageable by existing technologies without making that quantum leap to, basically a 100 megawatt system from, less than 100 kilowatts demonstrated. So that being said, I mean, the ultimate goal for everybody in this industry is the 100 plus megawatt floating platforms and systems like that. So we are all working towards that end. As far as the environmental implications and whatnot, I do agree with you that it would be better to demonstrate at a smaller scale and get a good idea of where the discharges have to be placed, what kind of impact it has on the fisheries for the intakes and the discharge, et cetera. I don't anticipate any serious issues with that. I mean, we've been doing this for a long time. We've been watching what goes on at NELHA, the National Energy Laboratory of Hawaii, and what happens there. The benefits far, far outweigh, in my opinion, the negatives associated with the technology.
But without a pilot, especially a pilot in Hawaii, I mean, isn't it true that it'll never get past the permitting process? I mean, the state, in terms of their environmental controls, are they really going to allow such a huge plant to go forward without verifying that we're not going to have serious effects on the ecosystem in the ocean?
Right. I don't know the particulars about this project, about where it's going to be located or whatnot. I mean, it's very possible because the size of the plant, it indicates it's probably an offshore floating structure, which means that it may fall outside of state jurisdiction. I mean, the state has responsibility, I believe, up to 3 miles offshore, and it's very likely that this power plant will be outside in federal water or maybe even international waters at that point. So I don't know exactly what the configuration is. As far as passing the regulations, there's a lot of legislation and rules that have to still be developed by the NOAA and by the EPA in regards to Otec. I mean, they've been lagging a little bit in keeping up with the industry because, I mean, the big push, the last previous big push was in 1979 and 80, the last oil crisis in the United States. So they haven't done a lot of on the regulations and whatnot and licensing procedures. So those are going to slow down and delay any kind of development within the United States.
Very interesting.
Yeah.
Thanks for being with us today.
You're welcome. I appreciate it. Thank you very much.
Thank you.